Handling your data. This is a very important lesson in this course. In this lesson, I am going to cover the various database technologies we can use while doing system design for an application. Which of these database technologies are suitable for certain use cases, as well as in the end, I'm also going to cover a little bit about big data, as well as the different computing frameworks out there on big data. Handling your data. While designing your application in a system design interview, data design is a very good way to start your design. A lot of people do the system design for a database using ER diagrams. So, for the database model, they design an ER diagram on the whiteboard. It is a very good way to explain the system. It totally depends upon your interest level. If you feel that for a certain use case a NoSQL database is much better choice, then go for it. But in a lot of use cases, relational databases are still good, and it's very nice to go with an ER diagram as it explains the requirements of the system very well as your thought process also very well from a database perspective. There is a very important point mentioned at the last section here. The database requirement of a small website are very different from that of a large website like Amazon. So Amazon website has millions of products. So they have a huge database that is distributed across thousands of different machines. So consider the case of a small website like a student website. The entire website might be hosted on one particular computer, and the entire database might be hosted on one box. So the requirements are totally different. Relational versus NoSQL. Nowadays, these two flavors of databases are very common. Relational databases is a tried and tested technology that has been existing for around close to 30 plus years now. One key advantage of relational databases is they support transactions, and they are highly available and highly consistent from a CAP theorem perspective. But partitioning is a problem with them. So I'll come to it in the disadvantages of using a relational database. Um, there's one key thing here that is mentioned in the last point. A website like YouTube uses MySQL extensively and it scales very well. So it is a myth that relational databases do not scale. Yes, they do scale well, but they need special DBAs who know databases in and out to do that piece of work. Out of the box, scaling them for a person who doesn't know the database technologies, relational database technologies very well is not easy. NoSQL databases, on the other hand, are out of the box very scalable. For example, Cassandra. So advantages of using a relational database. As I said, it's a tried and tested technology. The schema has to be designed upfront before pushing data into DBs. It has advantages as well as disadvantages too. In certain cases, it suits the DB very well. It supports transactions. It's highly consistent and available. So, what are the disadvantages of a relational database? It's not easy to horizontally scale. So, earlier what used to happen was when people used to buy a box of Oracle and they used to store their data on it, and if they got needs for scalability, they got huge amounts of data, what they used to do is they used to get a beefier machine, a bigger machine, and started storing data in that. So basically they used to vertically scale it. Later the concept of horizontally came into picture, and it became very popular when the new products like MapReduce came into market. So horizontally scaling requires new boxes to be added in parallel, as well as boxes that have failed to be removed, and still it doesn't impact the system. This kind of scaling is suited for NoSQL databases, but distributed joins across relational databases are very slow, as mentioned in the second point here, due to which horizontal scaling in relational DBs do not work very well. And following strict schema across data that is not adherent to a particular schema is not easy to. For example, in certain cases like log file data, you do not have a schema, right? And still, if you want to store this data in a databases, this particular kind of data is not suited for relational databases. Last point is very important. If you have deployed or worked in a production database while using a relational DB, you might have realized that sometimes while altering a table or changing the schema of a table requires you to first stop the server on which the website is running and then make that change and then restart the server. So it's like, it's like hard booting the server. And this is something which is not needed when you go for NoSQL database, because you can change the schema on the fly. A big advantage in that case. NoSQL databases. So relational databases had some issues, like not easily horizontally scalable. Upfront schema design had to be done, due to which that led to the creation of not just SQL databases or NoSQL databases. These databases have weak transaction support. They do not have strong transaction support like relational databases. So they follow the model of eventual consistency. So basically, any update to a particular machine has to be propagated to other distributed machines. So the data would eventually show up over there at some point in time. It would be made available at some point in time. At this point, it might not be there. Usually, NoSQL databases do not have support for joins, right? Usually they do not have support for joins. Now there are many kinds of NoSQL databases. Three types I've listed here: key value stores, which is regular, like our DB, our caches, or in-memory caches as well, are like this key value pairs. Amazon DynamoDB is a good example. Then there are wide column databases like Bigtable, HBase, Cassandra. Basically, these are also very very nice databases. So I can give an example here. Facebook, we all use, and the Facebook wall. It is being said that in some blogs that the Facebook wall, whatever entry is being made ultimately goes into an HBase table. So essentially it is basically a single row of a table has multiple tables clubbed into it. So for example, if there is a user of an e-commerce website and his entry is there in a user table, and there is a orders that he is placing, so all his past orders are placed in an order table. So if you go into a wide column table, when you pull a user record, at that moment in time, all the past orders might be clubbed into the user table itself. So there is another column for orders, which is essentially the column will host the entire orders table of his past history. So at one shot, you can fire a single query, not only pull user information, but pull the order information at that moment. Document based MongoDB, these are very popular databases, very developer friendly, and they help to modify schema at runtime. And they basically essentially they store their schema as JSON, but they call it as BSON. Advantages of NoSQL: fast development, as schema can change at runtime without impacting the app. Highly horizontally scalable, easy support on the cloud. So example is Amazon DynamoDB is highly supported on AWS. It has come from Amazon only. It is easily scalable on the cloud. Most of these NoSQL databases have good support on the cloud nowadays. There are disadvantages of NoSQL though. One key disadvantage is eventual consistency leads to different type of defects, that are sometimes hard to debug. So in one of the quotes from one senior engineering person from Google, he has said that eventual consistency can sometimes lead to such defects that in some cases distributed joins are still good, distributed transactions are still good, and they are not bad, and you should consider using them. So no distributed transaction support in the last point mentioned here for NoSQL. Let's talk about scaling your data. So how do you scale a website? So you as a startup, you built a website that had small amount of data. Now the startup has grown a lot and you have tremendous amount of data. So how do you suddenly scale your website to suit to these needs? There are three main techniques that we use to scale our data. One is replication. Replication, as the name suggests, is basically copying your same data across different machines. And the key advantage is it helps to distribute your read-only traffic. So you have read-only type of data, you distribute it across multiple different machines, and when the hit comes or the request comes for that data, you use a load balancer in front of your machines and distribute the load to different boxes, and and serve the read-only traffic from there. The second key technique is sharding or partitioning. It is a very important technique. The idea is you distribute your data, you cut your data in chunks and distribute it into multiple machines. For example, one way of partitioning is range based partitioning. So suppose you have IDs of users from 1 to 100,000, right? So and you get 10 boxes. So from 1 to 10,000 you put in box 1. So from 10,000 to 20,000, the entire set of data, you extract that chunk, put it in box 2, and same way you distribute in all the boxes. Now when the hit comes for a particular kind of request, or you need to pull information, user detail for a particular user ID, you figure out the user ID. From the user ID you will know which particular box you need to go to. Of course, this has problems, like when a new box needs to be added, you need to recompute everything and redistribute, or when one box goes down, then you need to redistribute. There are techniques like consistent hashing that you can use in this case that will help help you fix these issues. Amazon DynamoDB supports this by default. You can refer to the reference section for reading more about consistent hashing. Last technique, data caching. This is an excellent technique for performance handling, and it helps to in the performance enhancement of your database. Basically, you use an external cache, and for data that is not changing, you just push the data into an external cache, and when a request comes for data, you first look it in the cache. If the data is there in the cache, you serve it from there. If it is not there in the cache, you can pull it from the database. There are various ways to update this cache. If you're using distributed cache like Gemfire or Hazelcast or Redis, you can even offline update these cache. So you can write a batch job that can read the data from your database and update these cache. There are various techniques in that. Refer to the reference section for reading more on these topics. So when do you use what kind of database? So a general concept, relational databases are very highly available and highly consistent, and they support transaction well. So if you have a website that is mainly for CRUD operations, create, read, update, delete kind of operations, go for relational databases. You don't have that huge amount of data, it's a simple website supporting typical CRUD operations, go for it. Or you can even say in interviews that I'm going to start with the relational database, but scalability is an iterative process, right? So scalability is something that you can iteratively build, so you can always eventually migrate your data to a NoSQL database and start using it. You can give examples of different websites that did that. For example, Twitter did that, and Pinterest, they use different NoSQL versions. Later they came up with their own version of MySQL. So a lot of this information is available on highscalability.com. Feel free to read it from there. Now I mentioned here that relational databases provide consistency and availability but lack partitioning because of distributed joins and shared indexes. So these distributed joins are very slow, and updating shared indexes across distributed boxes is a very slow operation, so it doesn't scale very well on relational databases. NoSQL fixes these issues. So they support loose consistency, as I talked before regarding this, in the form of eventual consistency. And NoSQL databases are very good on the cloud. So even if you are asked to build an e-commerce website, that the interviewer says has the scale of Amazon or Macy's or Target.com, so these websites have huge amount of data, then it is always a good option to choose NoSQL database. Okay, here I want to give another example. Sometimes the data is very raw, as in the form of log files. So a lot of people push it to NoSQL to analyze it later. There are other ways to do it as well. Some people dump the log files directly in HDFS, which is a distributed file system. so that you can write a batch job on top of it to eventually go over it and read it and produce the results and in a batch mode. So if you have time at your disposal, if in an interviewer tells you that I want a 4-hour job running in the background every day to cut out an analysis report for me from clickstream data, think about doing it this way. Like you can say that you can push the data into an external HDFS drive and store it there and write a batch job on top of it. So database design from system design interview perspective. So it is a very good practice to start with database design in a system design interview. Not only it clears the requirements for you, it helps the interviewer understand your thought process in terms of data. So the good way is to build an ER diagram. When you're building an ER diagram, I think it's not a very good practice to go in a lot of detail for it. So I think we should just spend around 5 to 6 minutes explaining the ER diagram, the key tables, and one or two key primary columns, that are joined or passed around. Other than that, if you go too much in detail, it will eat away the time of other sections. So here is an example of an ER diagram for an e-commerce website. If you see here, not all the columns are mentioned, but it contains some key columns. The tables here, 3 tables are important: customers, orders, and order details. The customer table contains a primary key, customer ID, and which is shared in the orders. So customer is placing an order, so from the order table for a particular customer you can get his orders, and the order contains a link to the product table, so what the customer is purchasing, so that information you can get from this table. So while explaining this, even though we have drawn other tables, but these 3 to 4 tables are of key importance here. So let's talk about big data. Nowadays big data is becoming more and more relevant because of the huge amount of data that is being generated on a daily basis. As well as there are different streams of data. So it's clickstream is one data, IoT data is there. So there are lots of sources of data, and as such the amount of data is increasing. There are different ways of handling this data. I'm going to cover few of those ways. So big data is huge data as well as unstructured data. It does not follow a particular schema. To analyze this kind of data, there are 2 particular ways. One is in a batch mode. So earlier when MapReduce was not there used to be tools that used to run for days and hours to generate reports out of big data, for example spatial data, and but nowadays a lot of this stuff can be done at real time. So 2 common patterns for handling this amount of data is in batch mode is scatter gather and MapReduce. For handling data at real time, I'm going to talk about 2 small approaches. One is messaging. So basically you pump the data in messages. You have so if you are analyzing using a machine learning model, you have a pre-computed or pre-compiled machine learning model ready. So as soon as new source of data is pumped into a message queue, the consumer reads the message and applies the pre-compiled machine learning model, and you can analyze, you can do stuff like sentimental analysis on the fly on this data. So batch processing, scatter gather. So scatter gather is basically, as the name suggests, is a generic pattern that can be used on massive amounts of data. So the concept is very simple. So let me explain it with an example. So suppose you have a task that's taking 60 minutes on one computer. Now you distribute it on 6 computers that are almost as equal in their computation power to this computer. So you break the program, or you break the data into chunks of 6 pieces, and then you give it to each and every machine and run it parallelly. So you can get the task done in roughly 1/6 the time, that is 10 minutes. So this is the idea behind scatter gather. You scatter the data across different machines, and you write a program which is on top of that does the part of gathering or aggregation. So once the task is done on all these individual boxes, the data is accumulated, gathered, result is gathered, combined, and aggregation is done on it, and you can get the proper result. This is the whole idea behind the use of technologies like MapReduce and Apache Spark. So what is MapReduce? MapReduce is a program that is originated from Google, and even the search engine index that is being built by Google, it is said it is being built using massive MapReduce jobs. So it is basically a parallel computing framework that runs on top of a distributed system. So it wants the files or the data files to be present in a distributed file system called GFS, Google File System, which is very similar to HDFS. In fact, HDFS is actually similar to GFS as it came later. So the main task is broken into subtasks, and MapReduce works in two phases: map phase and reduce phase. So map phase is when you map the data and come up with key value pairs, and reduce phase is when these key value pairs are combined together to produce the proper result. So let's take an example, quick example of a word count program of how MapReduce will run it. So here in the below the input data section, I have two files containing the words, apple, orange, mango, and we have to figure out the number of words for each type of fruit. So the first subtask is the mapper task. If you see the two arrows coming out of the input data, and here in the mapper task, the data is broken into rows and sent to individual boxes. So if there are 4 boxes here, you can think of them parallelly running on 4 machines. Now map task creates key value pairs. So in the first box we have 1 apple, 1 orange, 1 mango, and same way it is computed for all the other fruits in other boxes. Then there is a phase called as shuffle phase. In the shuffle phase, the fruits are combined together according to their same type. So all the apples are brought into one box in one place together, and all the grapes, mangoes, they are brought into their same place. And then finally the reduce step occurs, where all these are aggregated, combined together. So essentially this is like a count in relational database, or grouping by type, group by, you can say, and you just combine it, and so you get 4 apples and 1 grape, and this way individually this is reduced and you come up with the final result. All these operations happen on different boxes. There's one key point here: MapReduce touches the hard disk many times between these operations, hence it is slower. Due to this, we came up with a new technology. A new technology was invented, and that was called as Apache Spark. Now this is supposed to be many times faster than MapReduce, because it doesn't hit the hard disk that often while computation. So it does a lot of processes in memory. Essentially it is just a lot of JVM processes running on individual boxes, and when it loads a lot of data in the heap memory of the JVM and does the computation over there, hence it is very fast. So as I mentioned, this is just the tip of the iceberg we have touched in this particular slide. In this particular PowerPoint presentation, there is a lot of information that we need to study from system design perspective for this. Some of the books I mentioned over here, here I would like to mention the first book, Designing Data Intensive Application. This is a very nice book that covers some of the database technologies in depth and explains each and every concept. The second book, Web Scalability for Startup Engineers, this is also an excellent book that covers some of the key concepts on database technologies. Thank you.